I'm recording and you're talking. He asked, though, I'll try and remember to delete this, but if I don't, he asked, how often do I delete the recordings from my computer? Basically, when my computer says I'm out of memory. So for for these first few, we are dealing with the rules for 45, 45, 90-degree special right triangles. So when I say 45, 45, 90, this is actually the leg opposite the 45-degree angle, which will be congruent to the other leg opposite the other 45-degree angle. And 90 represents the hypotenuse, which is across from the 90-degree angle. So we're going to represent each of the legs with the letter X, and the hypotenuse is going to be whatever the leg is times radical 2. I don't know if you can see that there. That's X radical 2. You know what I'm going to do for everybody so nobody can say they couldn't see it? Okay. Now, the first thing I don't like is I don't like that they then start using these X's here. I would rather the direction just say find the missing dimensions or the missing side lengths. If this is 45 degrees, then this is also 45 degrees, correct?
Yeah.
And if this is 7, this is 7. Go ahead.
7 radical 2.
Okay. And so the hypotenuse is 7 radical 2 because we take whatever is the length of the leg and we multiply it by radical 2. We just leave our answers in simplest radical form. Now, for the next one, since these legs are both congruent, they're both 5 radical 2, I know that they have to be opposite congruent angles. So since one angle is 90, the only thing these can be are...
Would it be 5?
Well, no. Okay, then you're going to think that this is 5 because of the formula, but hold on. So this is a 45-degree angle and this is a 45-degree angle. So X is actually represented by the term 5 radical 2. And I know this is a little confusing when you first look at it because you're expecting the radical 2 in the hypotenuse. Okay? So remember, to find the length of the hypotenuse, we took the length of the leg, in this case it has a radical in it, and we multiply it by what? So we're actually going to take the length of the leg of 5 radical 2, and we're going to multiply it by radical 2. So what is radical 2 times radical 2? It ends up being 2, because radical 2 times radical 2 is actually radical 4, and the square root of 4 is 2. So we actually now have 5 times 2. What is 5 times 2? 10. So the missing hypotenuse is 10. Okay? So now I'm going to go and do problem number 5. And problem number 5 lays out a bit more like what we're used to. In that, the 3 radical 2, does that represent a leg or a hypotenuse? Hypotenuse. So I'm going to actually use this color. 3, oh, that didn't change. Radical 2, I don't know if you can see that, represents the hypotenuse. Let me try it in a different color. Oh my God, if it would actually change colors. 3 radical 2. So if x radical 2 is represented by 3 radical 2, what is x equal to? 3. Okay? So now moving on to problem number 6. And what I found today is we need to refresher on rationalizing the denominator. So in this case, we already have the hypotenuse, right? It's 7. But that in our formula chart would be represented by x radical 2. That means whatever the length of the legs are, times radical 2 equals 7.
Would you do 7 divided by radical 2?
Okay, exactly. So you would do 7 divided by radical 2. but I want this in simplest radical form. It means I have to do what's called rationalize the denominator. You did have this at the end of algebra. I cannot have a radical in the denominator. Does anybody remember what you do in this case? Okay. So what you can do is you need to clear this. The way to clear it is to multiply top and bottom by this. So since it says radical 2 there, I'm going to multiply the top and bottom by radical 2. If I had another problem and said radical 3 in the denominator, I would multiply the top and the bottom by radical 3. Remember, basically I have a fraction there. Whatever you do to the top of the fraction, you have to do to the bottom. So you can have a radical on the top, you can't have it on the bottom. So when I multiply across here, I get 7 radical 2, and on the bottom, what do I get? 2. Because radical 2 times radical 2 is radical 4, which becomes 2. So the answer is C, 7 radical 2 divided by 2. We okay so far? Okay. So now we're going to move on to 30. Oh, no, we're not moving on to 30, 60, 90s yet. We got a word problem. Woohoo! So the square tile shown has painted corners in the shapes of 45, 45, 90. So if this is X, this is X. And so this is X, and 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 that's X. This is, it's hard to see, this says 2 radical 2. So this, don't do that. My pen was messing up. So I'm going to try and, hold on a second. Let me make sure my video is caught up with your hand. Okay? So I'm finding the side lengths, correct? The hypotenuse is 2 radical 2. That would be represented by x radical 2. So what is the leg? 2. Okay? If the leg is 2, how long is the side of the tile? 4. And by the way, then what's the area of the whole tile? 16. Okay? Now we're going to go on to our 30, 60, 90. Some of the answers are there, but I'm going to write my rule again. So when I say 30, 60, 90, I mean that the leg opposite the 30-degree angle is represented by x. The leg opposite the 60-degree angle is represented by x radical 3. Why? Because that's the formula. And the side opposite the 90, which is the hypotenuse, is 2x. So basically the side opposite the 90-degree angle will be twice the length of the short leg. Okay? So, once again, I don't like that they use x and y here because I'm using x in my formula chart. So I'm just going to say find each missing length. So here, 9 represents the side opposite what angle? The 30. So if x is represented by 9, what's x radical 3? 9 radical 3, correct? And what is 2 times x? 18. So the leg opposite the 60-degree angle is 9 radical 3, and the hypotenuse is 18. Now I'm going to go on to problem number 9. Okay? And this is why I don't like x here, because they have the x, I think, in this one. They put, well, that would work. It's the side opposite the 30. I still don't like it. Let's cross it back out. So they're giving you 3 radical 3 is the side opposite what angle? We just call it out. The 60. So 3 radical 3. So following this formula, following this chart, what is x? 3, and that's the side opposite the 30-degree angle. And then the hypotenuse is how long? 6. Okay? The last one gets a little bit trickier. 12 radical 3 is actually the length of the what? Hypotenuse. So this gets a little confusing. So you want to say, to find x, okay, you're actually going to take 12 radical 3 and divide it in half, correct? When you do this, nothing happens to the radical 3, does it? What's 12 divided by 2? 6. So you have 6 radical 3. Now, to get the side opposite the 60, I have to take the leg opposite the 30 and multiply it by radical 3 times radical 3 is 3. Because radical 3 times radical 3 is 9, is radical 9, square root of 9 is 3. So, hold on a second, let me just write this. Why did I divide this? Because 2x is equal to 12 radical 3. So I want to divide this by 2 to undo that, okay? Does that help now? So going back here, so I have 6 times 3, so 6 times 3 is 18. And you can check in your calculator, radical 3 times 12 is approximately what? Somebody just tell me so you see. 20-something? So you can see it is larger than 18. But you need to know these rules because when I ask them on a test, I'm going to ask for them in simplest radical form. It also is much quicker. And by the time you get to chapter 11, if you can't do these rules kind of quickly, you're not going to have enough time to get through the problems on the chapter 11 test. Okay?